Boa tarde a todos. Eu vou fazer uma pequena introdução antes de iniciarmos a mesa 4. Eu preparei um texto que vai contextualizar o tópico da mesa, que é a teoria post-tonal, e eu vou ler esse texto em inglês bem devagar, para ficar bem claro. Tá? Então, it can be said that the first steps towards the development of a post-tonal theory, which explained the music of the first half of the 20th century, 17th school, as well as European and American integral serialism, were dated by Howard Hanson and Milton Babbitt. Hanson, in the 1960s book, Harmonic Materials of Modern Music, demonstrates involved symmetry in a modular space and proposes a taxonomy for these intervals. It's called the PMNSDT system. That's right below here. And Milton Babbitt, for his part, is the first one to use the term pitch class. And the concept of Model 12 in his 1961, 1 year later, 1961 paper, set the structure as a compositional determinant. But only in 1973, with Alan Forte's release of the structure of atonal music, Hanson's ideas expanded, formalized, and quantified. Almost in parallel, 7 years later, in 1980, John Runn, following Babbitt's line, publishes the work Basic Atonal Theory. An interesting fact is that these two paths present a different algorithm for normal shape calculation, which results in slight difference. Nomenclatures of the operations are also differentiated. In 1987, two key works for the expansion of this theory were released. It's Compositional Design with Pitch Class by Robert Morris, which will be on this round table. This book advanced the application of this theory in the field of composition, while David Lewin, with his generalized musical intervals and transformations, as GMIT, deepened the analytical tools. The former expands the theory directly from John Wren, and the second performs an epistemological convergence of Babbitt's work with transformational theory. 10 years later, Joseph Strauss popularized the theory with his introduction to post-tonal theory. And this educational aspect is also followed by Miguel Roig Francoli with his Understanding Post-tonal Music. Then we have tentative genealogy, starting with Babbitt and Hanson, which are called the ancestors. Then we have development of the theory with Forte and Runn. A generation that expanded the educational aspect, and Lewin and Morris. Lewin for the analysis tools and Morris for composition. In Brazil, we have the pioneering works of Ilza Nogueira, he is here, and Jean-Marie Oliveira. One can think of a second generation of researchers who use this theory, Paulo Costa Lima, Celso Loureiro Chaves, Marcos Lacerda, who was here this morning, and Carol Bernikoff. Carol is here. Worth mentioning, Jean-Marie Oliveira Pisciene, processador de classes de notas. You can do the calculation of the style of John Runn. A third generation is represented by Rodolfo Coelho de Souza, who draws his research from Forte, Strauss, and also Pearl and Dewey. And a fourth generation, Paulo de Tarso, who's going to be on this table, and Bordini too, who recently translated Strauss' book into Portuguese, this book here. So basically that's it. I think we're going to start with Robert Morris. I'll talk a little bit about you and then call you to the table. Robert Morris, doctor in musical composition and ethnomusicology from Michigan University, professor of composition with additional affiliation with the theory and musicology departments at Eastman School of Music and Rochester since 1980s, composer of more than 160 works, including computer and improvisational music, author of 4 books, and the 5th one is coming, and over 50 articles and reviews which have appeared in the most important journals of the world, contributing to the theories of musical analysis and aesthetics, composition design, and electronic and computer music. So, Robert Morris.
So I'm going to be talking, in fact, Liduino actually summarized some of the things I'm going to say today. I'm going to go really quickly through it. What my paper is about today is about thinking what it means to write a theory that's for composers, as opposed to theory for analysts. And there are a lot of differences. I'm going to talk about those differences today. So our first major theory in the 20th century in compositional theory is, of course, the 12-tone theory of Arnold Schoenberg. But at the same time, 2 other people were working on theories not about ordered sets, but unordered sets. As Howard with his tropes. A trope is a hexachord, and all the other hexachords are transpositionally related to it. Not inversion, but transposition alone. And consequently, that means that 44 tropes. Liduino invented a series of scales that are also, in this case, transpositionally invariant. He calls them modes of limited transposition. And they include the chromatic scale, of course, the whole tone scale, the octatonic scale, the scale without an augmented chord, etc. And he uses those in his music pretty much constantly until around 1950. Then what Babbitt did is he took Schoenberg's ideas and through analyzing Schoenberg's music, he developed a much more robust and deep theory, which I just call serial theory. It's about ordered sets, usually in 12-tone rows, but it could be something else, it could be hexachords. And it applies to works of Schoenberg and Webern and etc., but also to the works of Stravinsky, in the last period of Stravinsky's work, and also to some of Boulez's ideas. At this point in time, 1973, as was mentioned, Alan Forte's book came out. This book was really for analysis. It was not a book about composition at all. I'm not going to take much time on it, but I'll just say that that book was actually was Howard Hanson's theory rewritten in a different way. It's isomorphic. Every concept that's in the Forte book has its connection to that Hanson. Elliott Carter, while he didn't publish his work at that time, worked out the exact same theory for himself for use in his own compositions. So what's on the left side is ordered sets and 12-tone rows, and what's on the right side are unordered sets. Then I came along and I thought this whole thing was silly to make a distinction that was based on order, because you could make order a transformation, just like pitch classes are transformations. And so I combined all these theories into one with the other things that were going on too. So in my book, I talked about 3 different kinds of pitch spaces. And the reason for this is that when we listen to music, we may not be aware of some of the details in the mechanics or the syntax of the music, but we certainly can hear other relationships that are important. And the first one is contour space, where things go up or down or stay the same. I'm going to find people already giving papers here about this. So we have only 3 intervals. The 2 notes or 2 themes, one's higher or lower than the other, or the same. Then the second part is pitch space without octaves. It's just the same interval repeated over and over again. It's linear, and it doesn't have a top or bottom in principle. A lot of composers compose in this space and don't care about octaves. However, we have this is the pitch class space, the 12 pitch classes, 0 to 11, and it's a cyclic space. Most analysis is about pitch class space, but they miss a lot that's going on in the music that especially the listener picks up, that have to do with contour and exact intervals going up and down. I think we've had some of that in previous talks here. This seems to be pitch class and pitch. Now, on the other side of the screen, I have the isomorphisms of these spaces to time spaces. So the first one is sequential time. That has 3 intervals in it also. The intervals are before to now, now to next or after, and staying at now. So it's exactly like the contour space, except it's in time. The second one is linear time, which can be measured in seconds or beats, and it's a series of beats going on and on and on, and you can measure things from it and put things in that space, right? Just like the pitch space. And then we have cyclic time. That's where we have measures and metrics. In the case we want to make an exact correspondence to pitch class space, we take a 12/8 measure and we have 12 beats in it. And those 12 beats can be represented by numbers, and those numbers can be automatically translated back to pitch classes or stay in the time domain space. This is cyclic time. These 3 are isomorphic. They have exactly the same structure. They don't sound the same way at all, of course. Well, no one's saying that if you listen to something in pitch space, you'll be able to identify immediately that transformation into the space and time. But the relationships that are among things in these spaces are translated. So, for example, in pitch class space, you have transposition, right? Okay, so everything is you add a number to it, and it cycles around. The same thing happens in a measure. You can move the figure of the measure forward or back in the measure, forward at that time, and that's like transposition. Okay. And all the invariances and subtleties that you can have in pitch space or the pitch class space can be translated to time. So, what I did in my book was discuss compositional designs, and these were simply arrays, 2-dimensional arrays or matrices, which had numbers in them, and the numbers represented pitch classes, and you could compose from that. You could be looking at it sort of like a lead sheet in jazz, where you have the chords written, and you thought you have to do this chord first and that next. And it's similar here, so you have a bunch of pitch classes in columns, and in the rows going across, you take those in time. It's the simplest explanation. Now, the book then covers aggregate combinatoriality, which is one of the things Babbitt talked about in his theories, non-aggregate combinatoriality, which I more or less invented by myself, and found later that it was very useful to look at Carter's work from that point of view. Generalized aggregate partitions, I won't even get into that, but it's very interesting. Rotational arrays, which of course are the things that Stravinsky used in his music, and also got picked up later by certain English composers like Ollie Nelson. And then some embedded pieces and array, those are ideas where you have a linear line of things, and you pick out a set of notes from this linear thing, and it turns out the picked out notes are the same relationship to the whole sequence. So it's an embedded relationship. Now, after I wrote my book, I realized I hadn't talked about something that's really quite important, and that's a compositional space. And that's just this collection of entities arranged in patterns to help generate compositional designs and forms of improvisation. And these patterns and relations are not in time, they're out of time. The distinction was made from Xenakis in the previous talk, out of time and in time. These are out of time patterns, but they can be put in time. This is an example of an array. It's for a string quartet, and it has 2 lines played by every one of the instruments. You can see that in violin, there's a bottom line they label 2, and there's a top line. In the string quartet, I distinguish between these lines by having the bottom one be pizzicato, the top one be arco. And all the string instruments have this relationship, but the columns in this are all the 12 tones. Each column is every 12 tones. But every column is a different distribution. So that makes every time you do the column a different compositional problem, or a task, or an opportunity. So that's an example of a pitch-place array, or a compositional design. This is an example of a compositional space. This is out of time. That first matrix up there works so that if you think of yourself as a rook in chess, you can move, anytime you move this way or down vertically or horizontally, you get the 2 cells that you pass will always produce an all combinatorial hexachord. All combinatorial tetrachord. So if you start up there with CE and you go to the right, you get A sharp. That produces one of those tetrachords. Or if you go CE to F sharp G, you get another one. Or if you go from CE to D sharp A sharp, you get another. And you also can wrap around, so you can go from CE down to F sharp and C sharp. And no matter what you do in this space, as you go stepping around like this, you always get the same basic sonority. The same is true in the bottom, and this space is even easier because everything, what's going on in diagonals are one set of diagonals, like one digit in chess, are minor thirds, and the other diagonal is the tritone. So in this case, if you don't even need this space, you want to also understand that if you play a tritone and any minor third that doesn't intersect with it, it produces an audible tetrachord. So these are ideas, you see, that can be used by a composer you can improvise with, or to make a compositional design from. So now looking at that chart again in a slightly different way. 12-tone theory was certainly a compositional theory. So was Hauer and Messiaen. Serial theory was both compositional and analytic, and the reason why is because that introduced some technical tools that can be used to analyze music as well as compose it. Hansen and Carter were both compositional theory, but notice that Forte took the same theory and used it totally for analysis. And he was not interested in composing from this. Then, when I drew on all these different theories, I made a compositional pitch-place book, which is a compositional theory. And I've been surprised sometimes by people going into it and saying, this is a great analytic theory, I can use it to describe things. Well, that's nice, but it's not what I intended. Now, generalized music intervals and transformations, which has a lot of crossover into my book, is a very analytic theory. It doesn't, what it wants to do is usually parse down the things that are going on in a composition in the simplest possible way of describing them, so that you have a nice model of the composition. But this model of the composition doesn't generalize. So, and we're going to talk about that right now. So we're going to talk about some issues that happen in analytic and compositional theories. And these get confused because they use the same theoretical concepts and terms, but the reason you're using these theories is different. So in an analytic theory, you've got many objects, and the analytic theory is going to take those objects and show which ones are connected to some basic idea. So you look at pieces, you take all the sonatas, or you take all the ABA forms, or you take all the pieces in B flat, whatever that is, it reduces to one thing, one idea. It's determinate because a many-to-one mapping is a determinate mapping. It's reductive because it reduces multiplicity into singularity. And it's algorithmic because if you have a reductive theory that works right, you can write a code that will do it automatically for you. You don't have to do the work yourself. Compositional theory is quite different. you're starting with a theory and you want to generate many different things. And which one's going to come as a use of the theory is indeterminate. If I propose using some Renaissance counterpoint and you do, we'll write very different pieces perhaps. But they can reduce back to our rules, but the idea is we're composing from these rules. So it's indeterminate, it's generative in the same way language is generative. We have a bunch of syntactic rules and a vocabulary, put it together, and we generate sentences you've never heard before, like this one. You've never heard the sentence before because you've never heard it before because you've never heard it before. Okay? And therefore, the whole technique is heuristic. It's to discover. It's not to analyze, it's a discovery process. Okay? Now, compositional theory can be used in analysis by reverse engineering the theory. So you have the theory now generated to analyze. Okay? Second issue, closed and open compositional theories. I mentioned 16th century counterpoint a minute ago. The ones on the left are closed pretty much. What they're going to do is generate a style of music. You cannot get 12-tone music out of composing with 16th and 18th century rules. It just doesn't work. All right? Hindermith is a great example of this. Hindermith were a very fine and well thought out theory in his book, The Craft of Musical Composition. And anybody who follows that theory will write a really good piece in the style of Hindermith. So it works, but are you interested? Okay. So on the other hand, when you have on the other side, you have these open theories, for instance, group regularities in many styles of music. So 12th century is a good example of that. If you know the music of Weber and Berg and Schirmer, you'll realize they're really quite different, and they have different styles and different ways of going about things. And in fact, anybody who uses 12-tone theory, etc., to make something will write a lot of different kinds of music, right? And so there's no style associated with it. So it always makes me a little annoyed when I hear somebody say, "Oh, you're writing the 12-tone style." I don't know what that is. Okay. Then Hansen is an example of this also. His harmonic materials in 20th century music. He says, here are the sets, here are the harmonies, and here's some of the properties they have. Go for it. Then we have an issue of particularity versus relative abstraction. Theories could work on the left side on materials and local transformations. You get an idea, let's say 5-note motif, and you say, well, why can't I do this? Why can't I do this? Well, maybe I can transpose it, that's part of the theory. Or maybe you can retrograde it, or maybe I can add something to it. This kind of a theory is very sensitive to the character of the materials, how they feel, the quality of them. And usually the techniques occur in picture rhythm and texture and camera. And it's a bottom-up method, essentially. You start with small things and you build something else. On the other hand, you can work on the abstraction side and think about the form and global structure first, or at least at the top, then get the regularities you need, and then those are usually expressed in terms of pacing and time, how fast things go and how long they last. And this is a top-down theory. Now you can mediate between these two levels of particularity and abstraction if you have a syntax, that is, a set of rules for how you proceed. Okay, so syntax is important because it unifies the small considerations and the large considerations. All right, now we get into what kind of compositional actions actually do. If you think of this word poiesis, it means making something out of nothing. And it doesn't describe what the thing is for. But of course, composers are not composing just for the sake of it. Of course, maybe they are, but they have other interests too. So for instance, a compositional action could influence the experience of the listener, so the listener could sense the flow, the process, the sectionalization, the mood of a piece of music without knowing much more about it. All right? So they get an experience from their composition. You might be interested in influencing the perception of musical forms and entities, so you want people to recognize themes. You want them to recognize a key change. You want them to recognize that this configuration of sets is different from another. That's a more technical way of listening, but that's the way music lovers and people who are in the know about music listen. But you might want to do just the opposite, like a lot of 20th century composers. I want to get away from those themes. I want to get away from all those sexualizations. I want to go maybe to the top level there, that influence the experience of the listener. So it's a seek to, you're trying to seek to avoid the perception of musical forms. Okay? All right, and then the following is, maybe your compositional method has no bearing at all on how people listen to your music. You do something, it goes also in the piece, and then they hear it anyway. You don't care whether it's one way or another, or if you do care, you'll accept a lot of different ways of interpreting. So here's an example from poetry. Rilke, the poet, found that he could write really good poetry if he had a rotten apple in his desk. The smell of the rotten apple apparently made him write good poetry. Of course, when we listen to Rilke's poetry read or read it, we don't smell any apples. So this is an example of a compositional method, having the apple around, that doesn't result in anything for the listener. Those are all possibilities for compositional theory. Now, we might think about this distinction between musical things and changes of musical things. That's been a talking point in many of the talks so far today and yesterday. On the side of musical things, Hansen and Forte are interested in the collections and the chords and the sequences you can get. And then they look at the properties of the pitch classes, the sets, and set classes. And they have classes of things. In tonal music, we have such things as tonics, scale degrees, chords. These are all musical things, entities. Even in textural music, we have different kinds of textures and sounds. Okay? That's different from the other side, where, and Lewin is a perfect example of it, he's interested in the transformations, how things change, what stays the same under transformation, what doesn't. And then he has a very good model for that, of course, group theory, which deals with a collection of objects that change into each other, okay, but they are in a predictable kind of way, and they're closed. So what you get there with using groups is a kind of syntax, but it's still open because there's no beginning or end point. Any of the elements could be considered zero is another way of saying that. So what you've got there is a way of producing a closed system of transformations, but one that doesn't close in time. And also recursive tonal structures like Schenker is a good example of transformations too. All right. So Schenker is on this side of the equation, and let's say traditional way you would teach theory in a classroom is on the other side, entity oriented. See, and these two are opposed in some way. There were even fights in the 90s about Forte being an entity orientation and Lewin being a transformational, and the transformational was better, and things like that. I think it's kind of worthless because these have their merits. Anyway, if you have a thing, you can transform it. If you have a transformation, you need a thing to show us the transformation. So, okay, and this is going to be more technical, but I'll try and go through it quickly. In Lewin and Pearl, we're talking about combinatoriality, which is, of course, two rows that the first hex chord in each row together produces 12 tones. And here's an example, P and IP. All that they would say about this is, here's P, here's IP, okay? And they're related by some transformation. We don't even have to know that transformation. All we know is that if we transpose the example up there, like for instance down here by 1, you get the same relationship, you get combinatoriality. So you don't have to know the transformations, all you have to know is that these things will stay the same under transposition, okay? But there's a little problem here. And if you notice that the relationship in the P and IP row, that example up there, do you have a clicker or something? Thank you. I don't know how much time I've got left, so if I've only got a second, maybe I should go through this to pull together. But here, we have this 0 goes to 1, 2 goes to 11. That's an indication of a T1I relationship. Down here, when you transpose these rows up by a semitone, now it's 2, 1, and 2. That equals 3, 3 and 0. So what happened is the relationship between these two sets changed. But it's not given by this method of Lewin. He just doesn't tell you about that. But if you're playing something or doing something, all of a sudden you're going to realize that this sounds different than this. These are transpositions of that. So the notation hides the problem. But the notation depends, of course, on the context of combinatoriality. That can be very nice for analysis. There's a simplified analysis down to what you really need to know. But it's not good for composers. Because composers want to know what's happening when you make a transformation. So over here you have, against the same ones again, and then we transpose both rows by T1, that's what you get here, and we get T1 and T2I of P, all right? And these are not related by T1, but they're related by T3. Why? Okay, First of all, you have to understand that when you have an entity A transformed by T and I into B, you could show that A equals and B together equals N. So these two elements added together give you the N there. And then, so think about this. When we take this, these two elements, add one here and add one here, we're taking the original element and adding 2y to it, which is the transformation. And that's what we get over here when we get through the algebra. You get over to here, you get the right answer. But this is a cumbersome notation. There's a much better way, but it's more abstract to do the same thing. Here we have again our example. Here we have the other example. Now we're going to give some letters for these transformations. So H is going to be the transformation T1I, which is this. And G is going to be the T1, which is transposing this into this. And then we make a little diagram. This is called the inner oromorphism of H. Okay, and its result is at K. We plug in our variables, and we have to take the inversion of G, or inverse of G, and so that's T11. And then we solve this little sequence here. It goes along, I'm not going to explain all the way. But when you get to the end of it, it gets you T3I, which is the right answer. The good thing about this is that this little formula of inner oromorphism can be used in any operators whatsoever. So you can be using it for other, like multiplication, or another operator is fine to use, and it's extremely useful. However, it's more abstract. The best way is to say, like Mead does, okay, if you have P and you have T1 or T something of P, just add a number to both and you got the answer. It's sort of like Lewin, but it keeps the operations around, so you understand how this changes to there. Okay, we have to add one to both of these, and then we're adding one to this and one to that, so that's why we get 2 here, and 1 and 2 here. It's very simple that way. So Mead is a good example of finding a nice way to talk about this problem, which is simple, but it doesn't generalize. The automorphism idea does generalize it. Now, what was the point of all that? The point was to say that these 3 different ways of doing something produced a different way of thinking about those entities. In the Lewin example, you had some stuff and you understood how they worked, and you didn't know how it worked. In the second example, you had some intricacy to figure out how things change. In the third example, you have that boiled down to its essentials. That changes the way you think about the whole idea of combinatoriality. Okay, so one last thing I want to talk about is, it's good to think about linguistics as a model for compositional theories, or any theories of music. You want to talk about, of course, phonology is the sounds of the language, morphology is the way you connect those sounds to form meaningful units, syntax is the operations on the morphemes or meaningful units, and there are 2 forms of semantics. I'll cover that in a minute. So in phonology of music, you have sounds, pitches, tunings, timbres. You arrange them from phonemes. For instance, it might be scales, it might be chords, it might be sets, it might be textures, it might be other things. And those are the morphemes, the things you're going to use to make the composition work. Then you have syntax, and that might be the rules of harmony, the rules of counterpoint, or it might be something that you deal with in terms of serial theory, which about repetition and transformations and recursion, things like that. That's all in this category. Right? Now, semantics in music is usually thought of as reference to something else. So music is said, well, music can't say anything about itself, and it really can't say much about anything else because it's abstract. But actually, many people think, well, what about, a piece of programmed music that has a plot or an opera? So that's an example of a reference to non-musical entities. The idea that process, where you can take a piece of music and you can make a model of a painting or a model of another form of art. Also, if homage is an example of that, where a piece is referenced to another piece or a composition or a composer, etc. So these are all referential. But semantics, too, is pragmatics. What are you using your theory for? Which is why I was talking about the difference between analytic and compositional theory. What's the use of it? And same thing about your music. What is your music for? Are you trying to rewrite music for other composers to enjoy, or other performers, or audience? Or are you writing music to express certain ideas you have? And etc. That's in the realm of pragmatics. And pragmatics means that music is always meaningful. I mean, so there isn't anything like people say, oh, the music itself, that's meaningless. Those guys in the 19th century, Hans Slick and others, were really wrong about that. There's no such thing as absolute music. It's always referential. No. The point is always pragmatic. Okay, that's it.
The next one on the table, Professor Paulo de Tarso, Bachelor of Music from São Judas Tadeu University, Master of Music from Paulista State University, Júlio Mesquita, PhD from Campinas State University, and postdoctoral from the University of California, Riverside, 2014. He's a livre docente in the Department of Music at USP, University of São Paulo, where he has been working since 2008. He has experience in the art of music with emphasis on music theory and analysis, music aesthetics, Brazilian music, and musical topics theory. Coordinates the TeMA Villa, Analytical Perspectives for Musical Villa-Lobos, a research work produced with CNPq. He has a book he brought here. I don't know if there's finished the entire.
Unfortunately,
There's no one. Total sold.
But I will bring more on the wall.
Okay.
For now, believe me, I have.
Boa tarde. Eu vou tentar alternar um pouco de inglês com português, de modo a me tornar mais acessível a todos, né? E, well, this communication was not intended as an original theory, but it raises as an analysis of Villa-Lobos music. I have been done this for the last decade, and I was dealing with a specific problem that is in sonata form by Villa-Lobos in his string quartets. I found an interesting problem that is the modulation section in the exposition, when he transforms kind of specific tonal area in a specific mode to another one. And I decided to make an experiment using Alan Forte's theory of genera, of PC set classes. Something is happening, my computer is not responsive, but yes, I suppose that rolling ball, yes, pretty much scary, yeah. I'm hypnotized by this colorful ball. Well, Alan Forte's theory of PC class genera is something, an attempt of developing his theory of singularity, gathering pitch class sets inside families, and these families will make some consistency. Wow, finally. Will bring some consistency to harmony in post-tonal contexts. And this is my idea to recall this theory along with another and more recent authors like Professor Morris, Clifford Callender, Joseph Strauss, and well, you will see. Since my computer gave the next step, I'm trying hardly, I swear. Wow. I suppose this is the moment I have to sing or dance.
Start again.
So, recalling the Alan Forte's theory, we have 12 genera. Genus 1, 2, and 3 make a supergenus 1 with atonal, whole tone, and diminished trichords acting as progenitors. Genus 4 is the augmented, using the augmented trichord 312. The supergenus 2 uses genus 5 and 6, and they were named by Forte as chroma and semichroma. Genus 7 is belongs to two progenitors, trichords 3-2 and 3-7, and he called it as chroma dia or dia. Supergenus 3 gathers genus 8, genus 9, and genus 10, and finally supergenus 4 gathers genus 11 and 12. And Fortes make consistency among these trichords using their interval vector to bring them some properties they share in each other. And my additional methodology uses, as I said, the system of genera by Richard Parkes, a former student of Alan Forte, and the parsimony graphs by Dalthat and Steinbach, the intercardinality functions split and fused by Clifton Calendar and after that by Joseph Strauss. The zones of voice leading by Richard Cohn. The compositional spaces and approximate voice leading by Robert Morris. And voice leading in the pitch class space by Joseph Strauss in 2005, and finally the similarity among pitch class sets by Rodolfo Coelho de Souza. Here's, as an example, I present the channels 4 by Forte. It goes from the trichord, the progenitor trichord 312, and its complement 912. It has two tetrachords and also their complements. And so we have 1, 2, 3, 4, 5, 6, 7, 8 pentachords. And okay, aqui 8 pentachords and their complement septachords, 11 hexachords, bringing a total of 33 pitch class sets. This is intended in Portuguese as a translation for pitch class sets, conjuntos de classes de altura. Is an acrostic I use in Portuguese. Well, that's scary again. Okay. I will try to make a graph, a tree graph, exposing the genus 4 in a schematic way, beginning with the trichord 312 and making some operations of transformation. And see, we can see the transformation to the tetrachord 419. It's a split operation where the pitch class 0 turns into by split in 0 and 1. And the same happens in this side with 4, 12, 24 when 0 comes to 0 and 2. And among these two tetrachords, we have the parsimony operation by half tone and no whole tone. That's the usual terminology I use. And so we have all the pentachords in these channels, and all these operations and these parsimony or split relations among them. See? And then we come to the next level, the hexachords. And it's interesting to me because we can see how communicative these PC set classes are and how shy they are on the other side. So we have the 620 that Bix now is an important set by its symmetry and have 4 connections. You see that? 4 connections, and one of the most communicative among them. And the other one, for the other side, 635, the whole tones hexachord is a shy one, an antisocial hexachord with just 2 connections. And that is my field of operation. I suppose I will try to make analysis of Villa-Lobos music using this kind of presentation as a compositional space. Another moment of panic.
More emotion.
Yes. Please. Don't do this. Hey man, dude, what are we doing Liduino is saying that it offers some time to think about what I'm saying.
Paulo, quer usar o meu?
Precisaria transferir o arquivo,
Você
né?
tem um pendrive?
Não tem um pendrive aqui.
Eu tenho pendrive aqui.
Tem, né? Então, por favor, acho que vai ser melhor. Talvez até se quiser usar aqui um PC mesmo, eu tenho em PDF essa apresentação, acho que fica mais simples. Eu acho que vai ser mais prático. Well, I'm so sorry. Let's resume my presentation. So we have a total of 33 PC set classes in the genus form by Alan Forte. And here is a similar operation made by Joseph Strauss using similarity operations and split or fuse operations starting from the tetrachord for 1 in this zone, offset zone, seria uma zona de distanciamento, né, a partir de 4, 1. And here we have the fuse operation where 0 and 1 fuse into, 3 and 2 fuse into 2, and so on. That's a sort of use of the same theory by Joseph Strauss. And that's my graph, and now we go on. Here I was tempted to make another graph, circular graph, using the voice leading zones by Richard Cohn. And here in my former graph, I don't use the complementary sets, the septachords and octachords and nonachords. Just I stop it in the hexachord level. But here I use all of them. As you can see, we have the progenitor 312, and then we have its tetrachords, its pentachords. It's a shame that my original presentation with animation is not allowed, but this is static model to do the job. And the hexachords, and all of them are disposed into the voice leading zones where the sum of its PC sets, pitch classes, will result in the number of zones. So 0 plus 4 plus 8 is equal to 0, and so on. In 419 we have 0, 1, 4, 8. And 312 is a subset of 419. So I put just the extra pitch class aside of the Forte number. And when we have something like this, it's a transposition of the original progenitor. 048 is equal to 159. The transposition. So I put the prime form entirely in this kind of situation. Okay? Well, here is the interval vectors of the genus form, and I will proceed to demonstrate in some cases, in instances in Villa-Lobos music. Let's pray for my cell phone to make music now. And I will show what happened here. It's the first movement of Villa-Lobos string quartet number 7. We have a diatonic theme, and then after that we have two transpositions, mi fa sol, and then sol 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 la si do. And this is the first region and the first theme of this string quartet. Then it proceeds to the transition area, and this transitional area leads to the second theme, that is an octatonic one. Okay, let's hear it. What amuses me in this passage is the transition and how Villa-Lobos could achieve this. What kind of transformation we have here? Villa-Lobos is known as a chaotic composer, but I'm dealing with a composer that uses the sonata form and makes thematic areas well defined in respective modes. And I was wondering if his chords, his progressions, and his cadences will bring some coherence to this state of things. Let's see. In the exposition, there is a recapitulation. There's an interesting feature because Villa-Lobos make the diatonic tetrachord la si do ha, and then its transpositions mi fa sol, and then sol la si do. And in the recapitulation, he uses mi fa sol like this, and now a surprising tetrachord do ha mi fa. Wow, what is this? And then do ha mi fa, the another one. This reveals peculiar conscience by the composer about the inversional property. Villa-Lobos uses exactly the inversion. If we take do, ha, mi, fa, 0, 2, 4, 5, it's a perfect inversion with an axis on 0, and then we have the 0 mapping into 0, the 2 mapping into 10, the 4 mapping into 8, and 5 and 7. So the expected sol la si do was replaced by its inversion. It reveals that Villa-Lobos was acquainted and familiar with that operation. It's a totally surprisingly featured in Villa-Lobos music. More than we have in the recapitulation an additional set that is the 734, also known as acoustic collection or Lydian, Mixolydian mode, or in Brazil, scala nordestina, northeastern scale. It extends the transitional area in recapitulation, bringing to the second theme on octatonic scale again. this octatonic scale in the recapitulation is transposed, so and it has two halves, antecedent and consequent, if we put in classic terms as by Will Kaplan does. No? So the consequent is the same original pitch from the exposition, as if Villa-Lobos was closing the form, reaching the tonic again, the hypothetical tonic, in this original form of the octatonic scale. Well, here, and I'm sorry that it will be beautiful if I have my keynote working now, sorry. We have the compositional space of these chords. In the red squares, we have the chords used by Villa-Lobos. All of them belongs to genus 12 by Alan Forte. The only exception is the 411 that belongs to genus 7, which in compensation has a similarity with the 3-chord 3/7 that is a twin progenitor of this genus. It's a complex genus with two progenitors. No? So we have the operations of similarity and split operations and parsimony operations among these PC sets, bringing from the melodic camada layer, yes, thank you, melodic layer, and bringing to the octatonic scale by its septachord, subset septachord. In the recapitulation, we use the 734. As you can see, it's totally consistent with the genus 12 by Alan Forte, with this only exception we have here. Another instance is the second movement of the string quartet number 9. That's a quite different and exquisite work by Villa-Lobos. In this analysis, I will investigate separately the melodic and harmonic layers. First, the melody. We can see the space now is the genus 1, the atonal genus by Alan Forte. The red ones are the actually used PC sets by Villa-Lobos. And the only exception outside of this genus is the final genus, the 8-2. It happens if we see the score, the genus, the preset 8-2 is here. All the other PC sets belongs to the genus 1. And here I investigated the inclusion relations considering the actual notes in the score, and we can see how many strong are these relations? See, we have 5 of 5 PC set classes included in this superset. Here we have 4 of 5, 3 out 5, 4 out 5, 3 out 5, 4 out 5, 4 out 5. So it's curious that the only one that is an exception in this genus is that offers the most quantities of relations, associations with the other ones. Maybe it's a problem of Forte's theory, but it's quite interesting, quite amusing. And now looking to the harmonic layer, see if we look into the score again, these chords, the left hand in my reduction, we have a not so parsimonious association among PC classes, but a curious path in this compositional space. Here we have a refinement of that, and here only the PC classes involved. And the only exception is this, the 521. And we have quite curious symmetry among these PC set classes. Here we have my pink panther graph. My pink panther graph shows the actual notes in the score, and again inclusion relationships. And so we have 1 out 5 among them, 3 out 5 among them, 3 out, etc., and 4 out 6 among them, 2 out 6, 2 out 6. These numbers are the PC pitch classes that both chords have in common. So, and finally, my last example is the exposition of Villa-Lobos Symphony No. 1. This is the main theme. This is a cyclic work, so it's a cyclic theme, and the contrabass will deliver the initial statement, and so it will be transposed. We have here the nona chord, 9/4, and their transpositions. Here we can see all these transpositions. I will play it. We have E minor, C sharp minor, A sharp minor, and G minor. All these put together results in an octatonic collection. But Villa-Lobos destroys this interesting possibility. He creates a cyclic octacycle, and then he collapses it. Because after the exposition, he never performed again the transpositions. So we will have the chromatic nona chord more prominent than the octatonic scale. And here we have the transition. I will play it for you. That's a reduction without an element. transitions leads to the second theme that is in mixolydian mode, diatonic collection. And it's interesting that despite the mixolydian mode is associated with Northeastern music, it has nothing of Northeastern, Brazilian Northeast in this kind of music. It's more quite Tchaikovsky or Strauss. And well, I suppose my time is okay. Well, how can we measure it now? Because I suppose it died a lot of time ago. So I will go to my conclusions to not disturb. And so what I can say is that the Forte's theory can be recalled and can serve as a good insight to see that transformation, this kind of transformation, alongside with more concerned with voice leading transformation. That was my interest in that presentation. And well, I think it's enough. Thank you for your attention and sorry for the disturbance.
Next presenter is Professor Ricardo Bordini, who has a degree in composition from the Federal University of Rio Grande do Sul, degree in conducting from the Federal University of Rio Grande do Sul, master's degree in music, and a doctorate from Federal University of Bahia, and postdoctoral internship University of California, Santa Cruz. He is currently associate professor at the Federal University of Maranhão. Has experience in arts, focusing on music composition, acting on the following subjects: music analysis, post-tonal theory, Brazilian music, music composition, musical performance conducting, informatics and hypermedia music, a tonal thread space, and composition algorithm. He also has also private pilots in his spare time.
Good afternoon, everyone. I have no idea what I am doing in this table because I misunderstood the invitation. I thought I was invited to discuss about post-tonal theory, but last week I received a message asking for a text, and I had no time. So my first attempt was to talk about the new operation for the atonal voice leading space, as first designed by Dr. Morris. And this new operation is simple. Traditional operations is some element connected to +1 or -1 to another. And this new operation deals with +1 and -1 operation. It's not a parsimonial operation, but I think it will bring interesting theory. Anyway, I will not talk about any of these subjects because I did my homework, and Dr. Rodolfo asked us to read some documents, and I read them. And I became very disturbed by what I read because I realized how ignorant I am, because I have no idea of what we are talking about, really. So, my text in Portuguese have some word games which are not translatable. So, when This is Google translation, so I don't know what crap is in here. So I ask you, I beg your pardon for this. Anyway, I will talk, the title of my presentation, no graphs, no nothing, is the scrutiny of the uncountable, unspeakable, yet audible. The search for unspeakable and countless yet audible things is sought by reference to the theoretical foundation of theory and music itself, and by that theory about it. It means unspeakable through the way of music as a language, and countless through its relationship to mathematics. The insistent methodology which I created, it's a methodology which insists in seek for what cannot be found. So the insistent methodology of the method of constructing the object of investigation is applied even though it cannot be constrained, so that the sadness emerges inexorable. There is a word game in Portuguese here which, as I told you, it's not translatable. The obtained results point to the failure of enterprise even before its beginning. And the author says goodbye to his ephemeral career after completion of this presentation. So actually it's a goodbye for very good friends I gathered during some time in this association. Sorry about that. I always start quoting Jean-Marie Oliveira. One of its maxims is, the more something else, the less music it is. I emphasize and repeat. I will not repeat, but I emphasize. Oh, okay, I will repeat. The more something else, the less music it is. This is the first proposition. The second comes from Torrano, whose ideas drawn from his introductory say to his translation of Theogony are here greatly reduced and simplified. The numinous cannot be described. I understand music here without defining it as a numinous phenomenon, as a kind of no describable personal experience. A discourse on the unspeakable presents an insoluble methodological problem and must be frustrated as discourse and falsify the presentation of its subject. If the qualification of the numinous is indescribable, it's not the objects that support it, and this can be said, described, and defined. So the discourse about the numinous is not about him, but actually about it, but about the objects that qualify him, and that is what we do when we speak about music. He further says of music, we know, this is a quote, we know many lies, saying things similarly, and we know if we will to give revelations. And his argument about the relationship between lies and forgetfulness and between revelation and remembrance seem fundamental, and to deepen them here is beyond the scope of this reasoning. And so my speech suffers its first failure because I made a mistake with the first proposition. To qualify the objects that support the description of music as belonging to the numinous, one needs to know what matter it is made, from what matter it is made. Somewhere I heard a songwriter saying that he was There's a problem. Anyway, she was saying that he devoted herself to studying acoustics because she wanted to work with the music that she said would be the sound. I think one can agree with that. However, it seems to me that the very subject of music is not sound. The matter of music is not sound, but the gas molecules in the air. So musicians maybe start to thinking about temperature and humidity because pressure is depending on this things. As Finkel says sound exists as differences in air pressure, mechanical vibrations in the middle ear, liquid vibrations in the inner ear, and finally as electrochemical impulses in the nerves that lead them to the brain. So there is a huge difference as sounding in the physics world, and it's transformed into mechanical energy, then into hydraulic energy, and then into electrical, chemical reactions. And so what we are hearing probably is not what is sounding. If it sounds, maybe there is no sound at all, except in our brains. Anyway, examples about the ineffable ephemerality of sounds, as well as the possibility that music can be used as a measure of the present, are delayed for someday, maybe. I know I forgot to say something important here, but I don't remember what it is. Someday maybe I will. Moreover, the sound configured as music for those who can hear it at least once persists in memory, but what is in the mind no longer has its original matter, but a false representation of it. Two properties emerge from this phenomenon. If we listen, we can remember, but more than that, we can imagine music with it, our inner ear, and we have never ever before heard it, and does not exist for anyone else unless it's played and someone listens to it. Be that as it may, the music goes on in time, and even this is psychologically countered by it. Two great streams of archaic time, since archaic times, Google is really terrible. In different ways, try to approximate music either by conforming to a language, or at least to compare its elements with elements of language, to approach it with number tautology and geometric concepts, like sets of notes and polyhedral models, for example. I will start with language. While it would be acceptable to speak of a grammar of music, or of a musical syntax or lexicon, or even of musical semantics, what is communicable meaning? What is this communicable meaning? I mean, what do the first 13 bars of Beethoven's Waltz time mean? Marcos Nogueira says, the gulf that has always been understood between logic and art, between an object that solicits through and an object that solicits perception, has, since the second half of the 19th century, at least blurred as it begins to understand both objects as something that is about to be built. However, just yesterday I heard the word logic, used several times in the speech of the colleagues. The fact that there is, at least as far as I know, in the languages I know, no words to describe musical sounds. I mean, how to describe the sound of a violin or the sound of a chord. It seems enough to me to conclude that the elements of language are observed in the falsified object and not in the music itself. Thus, music accepts any logic, and the reason for this is that it has no or does not conform to axioms. So anything can be said and accepted about it because we are always on the level of the objects that qualify it, and therefore they are false. Moreover, how many theories fail because at some point the logic of the system did not match what they wanted to explain, like some minutes ago. Okay, there are all the sets, but there was one that was out of the... So, theorists usually have to change the path of his theories to accommodate something in the music who is trying to say you are wrong, you don't are understanding. One has to think about the relationships between music and language here. And comparative research in this field is animated by the tension between two perspectives. One that emphasizes the difference between music and language, and one that seeks commonalities. I get Plato's premise that music and speech have a very obvious difference in their sound category systems. Although pitch is the primary basis for sound categories in music, such as intervals and chords, timbre is the primary sound basis for categories of speech. For example, vowels and consonants. Really? This is not. This is a quotation of Plato. Music's approach to mathematics propose something different because they represent the falsified object with numbers and use the numbers logic as if it were hers, the music. And math has axioms, but music does not behave or is memorized either as numbers or as geometric polyhedra. Volume 17, numbers 1 and 2 of Perspectives of New Music contains articles by Morris, Lewin, 2 by Lewin, Claude, and Brown, which were read in the set theory section of the National Conference of the Society for Music Theory, held in New York from November 1 to 4, 1979. Demonstrates the high degree of mathematical sophistication that theoretical speculation related to post-tonal theory had come to at that time. Except for Claude's article, there is not a single musical example in those articles. There are only mathematical formulas. I was a beginning student at the time, and I tried to read those articles. Sincerely, I didn't understand a single word. Okay. Definitely, theory about music is no longer from musicians who doesn't know mathematics. Plato already admonished those musicians who twisted the strings in the pegs by measuring the intervals without worrying about the meaning of the numbers. The meaning, he suggested, is no longer the same as what we are looking for today, and yet we are still looking for. Order seems to be important to music, and when order is removed or the flow of time measured in duration is disregarded, it's the properties of the numbers rather than the properties of the music that we are talking about. What numbers could make me hear? What numbers could make me hear the music from the first 13 bars of Forte? That music is a perceptual phenomenon and causes many different emotions is fact. But to talk about emotion, when we talk about emotion, we do it by reason, and again we face the problem of logic. I remember Paulo defining the concept of pre-compositional models, starting like this quotation: "Is anything and something else?" And he was right. Indeed, anything can serve as a model for composition because it does not need it. But how is music stored in memory, and how we remember music you already heard? And how do we use internal listening to create music? I have been trying to explain this to myself unsuccessfully, or find it strange how I remember some song when in the lectures leading up to mine, I heard several speakers here do it. Many of you, when have to sing something, say da 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 da, or say something like da 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 da. And in this, we don't store music in our brains like sounds without these syllables. At least in my mind, maybe your brains are different than mine, but when I try to remember some music, it comes da 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 da. Not no names, not sounds. Really, they are. I don't know how to explain it. Anyway, so let's go ahead because time is running. And that's just how the song I was pulled from memory popped into my mind. At this point, I already tired of applying this system method and having come to the conclusion that the failure of resounding, I say goodbye to colleagues, urging them to persist in their research because this musician will no longer write or talk about music, will be content just by doing it. I close this argument with the following proposition. I will create some music here and use notes as fast as I can in order to not allow my brain to take control over it. Okay? And then I will ask you something. What does this mean? What I meant when I create this music right now? What is the meaning of what I sang? For those who like textural music, let's try something different. What is the meaning of this? What is the difference between the first song I sang and this one? So now play attention please because I'm coming to an end.
is for questions. This is the first one.
Okay. Well, thanks so much. I actually have questions for the three, but maybe I'll start with the end. This notion of music being ineffable, that you cannot put into words or any other symbolic system, I'd say it's totally not only music. It's actually any human experience. And so, try to describe the taste of a good feijoada brasileira. You can't. And so I don't think it's a question of music alone. It's any human experience cannot be translated into any other symbolic system. What you can do though, or you can imply, is a metaphorical mapping. And that's what the whole enterprise of understanding one domain with the tools of the other. That's what we're doing here. But a comment on your last performance. You said, I'm going to do things as fast as I can so my brain cannot think about it. And yet you draw on different categories. The first one was jazz, the other one was textual music, the last one was, I don't know, Tchaikovsky-oriented, romantic type of music. So it means that your brain is actually in control in some ways, and you cannot escape that. But okay, so that would be my general comment. I'll leave time to others for other questions.
Perfect, Dennis. You got it.
Posso falar sem problema?
Tem gente assistindo do outro lado.
Tá certo. Ok, boa tarde. Respirar para tentar falar inglês. About your two sonorous example, not the end. You asked about some, if we can see some difference between them.
No, what was the meaning?
Oh, but if I remember, you asked something about the difference of meaning.
Between the first and second example.
Yes.
So imagine you asked,
Yes.
and I ask you now, your intention, your purpose of make them different. It is already a difference.
Yes, there is.
That's the meaning. Thank you.
I have a more general question, and that relates to Ricardo's talk, but more to Maurice's talk. Is about, if it's a very conceptual question, do we have a real syntax in music, or it's only something that we import from other fields where logic are really straightforward? That's the question.
This is a problem that linguists have when they look at music. They say, well, you can't have a syntax because syntax is about nouns and verbs and things like that. Or is it proof? Well, yes, that in science is the meaning of something is really true, right? So in that case, there is an understanding. But syntax generally for me would mean some rules of ordering. You have 7 things and then you decide which ones come after each and under what conditions. And that's what a syntax is. So a formal syntax would be probable orderings of chords, or the way voices will move, or the registers of things. And then sometimes they're explicit, sometimes they're implicit in the style, but people know how to do it. In fact, if you play jazz, you have to know certain chords change melodies and words and things like that. And that's syntax. Also, syntax can be used to build. So you have phrases and larger phrases. Let's see, I have a paper about the nesting of functions inside each other. That recursion idea is really quite important in syntax. So that's what I mean by syntax. And I would say that language could be thought of in this abstract way, but linguists tend to want to have nouns and verbs. In fact, for a long time, linguists did not consider sign language a language because it was not based in sound, didn't have phonemes. So, it's fine.
So in your opinion, we deal with real syntax?
Yes, yeah. As I find it, I mean, a linguist would say, well, no, it's not syntax because we need to have verbs and nouns.
Yeah. Okay. So, question for Paulo. Well, wonderful work, thank you. My question is, since you have a kind of a top-down approach, you start with the theory, then you look at the music, I was wondering if what motivated you to look at Forte's Genera was problems in the music, categorical problems in the music, or whether you developed your theoretical approach and then looked at developers for illustrations of that. I'm just curious about what was your methodology and your approach to this. Maybe I'll ask a question to Bob as well. The way you created this junction between the function of analysis and the function of the compositional field, that in some ways they were antithetical to each other or at least had different directions. I'm wondering, it reminds me a little bit of that Liduino article that he kind of responding to Beyond, right? Responding to Everticon, exactly.
The meaning of that was that code is not distinguishing theory
and analysis. Right, and the thing is that you don't put, you put theory, you put analytical theory, right, and compositional theory, so you kind of have theory in both. But it strikes me that there are a lot of analytical acts that are not only reductionist, right? I mean, if you think about categories and categorization, right? Well, no, the modern concept of categories actually, it's a prototype that's open-ended. So it's right. It's not that you put it in a box because it has certain features, but it's similarities. If you think about topical theory, right? So you find something in the music, and the analytical act is to take the concrete and to put it into a larger domain, so to speak. And so that's kind of not a reductive, so to speak, but it can lead to a theoretical framework that opens up as well. So I'm just wondering if...
If you accept that, and you accept that point of view, then you don't have explanation. You don't explain something. What you do is you have different ways of looking at it. So that's what goes on here. Categorization, as you define it, is similarity relations. Allows you to have different perspectives on the object.
Have a prototype.
Yeah, right. So reduction to the prototype. I don't know how to...
More closeness, right? But then the prototype allows you to bring... What I'm trying to say is that...
If you let the prototype generate, then it's a compositional theory. That's... Okay. Anyway, these are semantic problems that really aren't very important, because really what we're talking about here is, does a theorist or a composer have an imagination? I wanted to say something about Alan Forte's theory about Genera and why he developed it, and it might shed light on the question you asked. In his older theory, in structure-based tonal music, he reduced large sets to complexes, where the hexachords were the center of the complex. And the problem with that is you might have sets of a lot of different sizes, and you might only have that hexachord once in the whole piece. The actual hexachord, everything's around. And so that was kind of funny in a way that everything would be at the hexachord level as opposed to the local level or the highest level. So the genera was saying, let's go back to the trichords and put them together in different groups and generate all the sets from the trichord level up. And it made a lot of sense because it gets you to the surface. I wrote an article, I don't know if you know it, on this problem, and what I did is I showed that actually the genera can be reduced to the old theory by some operations on the various genera together. There's intersections and things like that. So I could get back to the older theory, and I didn't need to go down to the trichord level to get this. So I don't know what Forte's reaction was to this because he never told me. But at any rate, the idea of starting on the surface of something with trichords makes a lot of sense in terms of trying to discover a relationship, which is fine.
I've spoken to you sometimes about the composition spaces. Well, asking your question, well, my point of departure was the Villa-Lobos music, but it has so many things in that my discovering was in several steps and several moments of acquaintance with that music. At first, I was trying to prove that was a formal question in Villa-Lobos, and I was trying to, that's the main topic in my book, that Villa-Lobos was concerned with sonata form. I did, and when I was taking a close look to that kind of sonata form, I could see the analogies that he made upon the classical language, tonal language, and the jointer of themes and cadences, and so I bring to the symmetry as a kind of consonant language to Villa-Lobos. Well, I was satisfied with that at that moment and put an end in my book. Wow. But that question still rings in my head, and I was someday wondering about, wow, how this thing is put in motion, how Villa-Lobos go from one collection to another, how he makes a kind of modulation in that space. This third question could not appear in the book. It would be huge if I do it with all the 17 string quartets. You can imagine, like, the editor will kill me at that moment. So, and so I think my current research now is about the Villa-Lobos symphonies, and this is giving me some space to start about this question. So, when I was wondering about what makes a collection, a compositional space specific, and what makes going to another space, another area, post-tonal area, call it as you wish, and that makes me think about, wow, what Forte had said about, and what Parks had said about, what Morris had said about. And so I decided to put these theories together, fusing it together in what seems to me a reasonable step to make about this theory.
So I want to return to the problem of syntax, because what he's talking about, and he sees the sets related by similarity,
Right.
not by syntax.
Well, similarity could be a function of syntax too, but
Because a similarity is a network of infinite possibilities.
Imagine you have two sets that I see your point. It's a good point. In other words, you're not obliged to make a syntax from similarity. There's no reason you should do it. But if you want to do it, you can, and that is a syntax. That's right. Yes, exactly right. So what I'm saying is this idea of syntax is not something that's obliged. There's music that you might say doesn't have syntax. I think a good example that examples things perhaps in electronic music, or maybe minimalism or something like that, where there's just flow. And so the only syntax you can say is X goes to Y. That's it. So I'm just saying that when you can build a syntax, you can build it from many different kinds of things. And one of the ways is, what seems very intuitive, is things that sound somewhat alike probably go together. And then what order?
I just have a curiosity about Villa-Lobos music and about the genres that is uncommon in those pieces. If somehow they are marked in the composition, so structurally or in the temporality of the music. So if they perform some synthetic use.
In my book, I worked with the notion of reference collections, as stated by Joseph Strauss, and that was enough to that time, and I was satisfied with the possibility to hear, by hearing, to say, wow, that is chromatic, that is octatonic, that is diatonic. And the surface aspect was satisfying to me. We are tried with this is to look deep in that structure and make understandable how progressions were made. I think that channels theory allows me to see or to try to understand by a coherent process if Villa-Lobos was consistent with that kind of perception. And naturally, it's just a work in progress. I started especially for this conference, and I am looking forward to proceed with that investigation. But I think it's promising. I think it's interesting that it confirms my perception of that music.
Okay, we have to finish now. We have a concert 6.
So we have a conference at 4 and a half.
It's 5 o'clock at